In this video, we are going to work through an example of how to calculate the work done on an object on an inclined plane. So let's go ahead and jump right into this example. This says a 4 kilogram mass is pulled a distance of 5 meters up a plane, inclined at 30 degrees with a force of 34 newtons. The coefficient of friction between the block and the plane is 0.2. Calculate the net work acting on the block. So I've gone ahead and sketched out this situation. We have this 4 kilogram block, and it's on an inclined plane that's inclined 30 degrees relative to the horizontal. Now, we know that this block is being pulled up the plane with a force of 34 newtons. And our question is, what is the net work that is acting on this block? So to solve this problem, there's one crucial equation that we have to know in physics, and that is the work done on an object. Let's call that W. That's equal to the force applied to the object multiplied by the displacement of the object. So we need to know this equation in order to solve this problem. Now, in this example, there's going to be 3 different work values that we're going to calculate. The first is the work done by the applied force. So again, there's a force that's pulling this block up this incline with a force of 34 newtons. So the first thing we're going to calculate is what is the work done by this applied force. Then we're going to calculate the work done by gravity, which will oppose this force, and we'll calculate the work done by friction, which will also oppose this force. So let's start by calculating the work done by the applied force. So let's write W sub A for work done by the applied force. That's going to be equal to the force, which we know is 34 newtons, multiplied by the displacement. So in this example, we're told that the block is pulled 5 meters up the plane. So this distance right here of the plane is 5 meters. So the displacement, the total displacement of the block is going to be 5. So 34 times 5, that turns out to be 170. And when we're talking about work, our units are joules, so we'll say J. So that is the work done by the applied force. Now let's calculate what's the work done by gravity. So in this situation, there will be a force of gravity that's pulling this object straight down. Now, the force of gravity is calculated as the mass of the object multiplied by the magnitude of gravity, which we'll call G. So we'll say this force is mass, M, times G. Now, when we have an inclined plane like this, what we can do with this force of gravity is we can break it up into its components. So there will be one component that is perpendicular to the inclined plane, and another component that will be parallel to the inclined plane. Now, when we draw these lines like this little angle right here must be exactly equal to the inclined plane. So this will also be a 30-degree angle. Now, we also need to know what is the magnitude of this perpendicular component and this parallel component. So the magnitude of this perpendicular component is simply going to be the force of gravity multiplied by the cosine of this angle. So let's write that down. The force of gravity, which is mg, multiplied by the cosine of 30 degrees. Now, you might be wondering, where does this value actually come from? And to understand that, notice that if we draw a line like this, we can form a 90-degree right triangle, in which this is 90 degrees. Now, when we have a right triangle like this, if you'll recall the acronym SOHCAHTOA from trigonometry, the cosine of an angle must be equal to the adjacent side of the right triangle divided by the hypotenuse of the triangle. So the cosine of 30 degrees, it must be equal to this adjacent side, whatever this side length happens to be, divided by this hypotenuse. So this is the hypotenuse of the right triangle, which we already know that length is m times g. So what we can say is that if we call this side, let's just call this x for right now, the cosine of 30 degrees must be equal to the adjacent side, which is x, over the hypotenuse of the triangle, which is mg. So to solve for x, this side length, we would just multiply both sides by mg. So we'd find that x is equal to m times g times the cosine of 30 degrees. So that's what this side length is right here. So that's where this value ultimately comes from. And this parallel component of gravity, that's going to be equal to mg times the sine of 30 degrees. And where does this value come from? Well, again, let's refer to SOHCAHTOA. The s, the sine of an angle, must be equal to the opposite side of a right triangle divided by the hypotenuse of the triangle. So if we consider this angle right here, the opposite side would be this side right here, so let's call that x. And again, the hypotenuse is this side of the triangle, which is mg. So what we can say is that the sine of this angle, so the sine of 30 degrees, must be equal to the opposite side, which is x, divided by the hypotenuse, which is mg. And to solve for x, we can multiply both sides by mg. So x would be equal to m times g times the sine of 30 degrees. So this side of this right triangle is 30 degrees, and this is exactly equal to this parallel force. So that is why this value is m times g times the sine of 30 degrees. Okay, so now that we've established that, the next work value that we're going to calculate is the work of gravity. And in this case, because the block is on this inclined plane, we're only concerned with this parallel force of gravity right here, which is exactly opposing this force that's pulling it up the incline. So the work done by gravity is simply going to be this force multiplied by the displacement. So let's write that down. We have m times g, so m is 4. G, the magnitude of gravity, is 9.8, times the sine of 30 degrees. And all of that is multiplied by the displacement, which again is 5. So if we punch these values into a calculator, 4 times 9.8 times 5, that turns out to be 196. And the sine of 30 degrees, that's equal to 1/2, or 0.5. So really what we get is 196 times 0.5, that turns out to be 98. And again, we're talking about work, so we'll say joules. Now, in this example, we're going to say that this direction in which the applied force is pulling the block up the incline, we're going to say this is a positive direction. So what that means is that this direction in which gravity is acting, that will be negative. So we're going to go ahead and say that this work done is negative. So we'll put a negative sign in front of it. Okay, the last value of work we have to calculate is the work done by friction. So one other formula we need to know is that the force of friction, let's call that little f, that's going to be equal to the normal force multiplied by mu, the coefficient of friction. So we're told the coefficient of friction is 0.2, but what is n, the normal force? Well, the normal force is going to be the force that directly opposes this perpendicular component of gravity. So the normal force will be acting in this direction, let's call it n, and it will have the exact same magnitude as the perpendicular force. So it's simply going to be equal to m times g times the cosine of 30 degrees. And that comes directly from Newton's third law of motion, which says that if the block is pushing down on the plane, then there will be an equal and opposite force that is pushing in the opposite direction. So that's why this magnitude is exactly equal to this magnitude. So what we find is that the force of friction, that's going to be equal to the normal force, which is m times g times the cosine of 30 degrees, multiplied by the coefficient of friction, which we're told is 0.2. So this turns out to be m is 4, the magnitude of gravity is 9.8. The cosine of 30 degrees, that's about 0.866 if you punch that into a calculator, and then the coefficient of friction is 0.2. So if you punch all of this into a calculator, this comes out to 6.78944. So that's the force of friction. So the work done by friction is going to be this force multiplied by the displacement, which again is 5 meters. So we'll get 6.78944 times 5, the displacement. And that turns out to be about 33.95 joules. And again, the work being done by friction is going to oppose the force that's pulling the block up the incline. So we'll say that it's going in the negative direction. So let's put a negative sign out front. So now that we have calculated the 3 work forces, the very last step to find the net work done on this block, let's write that down. The net work done on this block is simply going to be the work of the applied force plus the work being done by gravity plus the work being done by friction. So if we fill in all of these values we just found, we get 170 minus 98 minus 33.95, and that comes out to 38.05 joules. So that is our answer for this one. That is the net work that is being done on this block.